All right, this video is for the try these examples for the law of cosines notes. So I'm just going to go through. You can, in this format, pause whenever you want. These are not required, but to give you extra help for them. So going back to this first type of problem, again, I'm going to draw myself a generic A, B, C triangle, and this is just asking me for one piece. I do want to make a note that if it's not as clear when you're solving for a specific piece, you know how to solve for all the pieces of a triangle. So if you're having trouble figuring out how to solve for one specific piece, kind of take a geometry mindset and start solving for some other things, and then hopefully you'll see something that will help you solve for the piece you're looking for. So when I fill in the given information here, I have this, and I'm looking for C. So again, because it does have me set up finding the side that's right across from this angle, it really is set up to use the law of sines quite simply. Like I can just plug in, I have all the right pieces. So here's what it would look like when we plug it in. Okay. And again, I would type that straight into the calculator, and then I would square root the answer, and that would give me that C is, in this case, is equal to 8.0. Which again makes sense because C is kind of small compared to the other two sides, but it is across from a small angle. Okay. And then what we did after this is we tried to take this idea into solving triangles. So that's what we'll do next. So here's the try these from the rest of the portion of the law of cosines notes. So I'm going to start with part A. And here in part A, if I draw myself a triangle, again, these are just pretty generic shaped triangles. All right, so when I look at this situation, this is a little bit different. This is an angle side side situation. So we want to make sure, oops, sorry, I labeled it in the wrong spot. So it's not an angle side side situation. I was like, the letters don't make sense. Here we go. I'm sorry about that. So notice C is across from C. So I fixed that. And so we have side angle side, which means there's one triangle here. As I go to solve, that's important for me to know, because if there's more than one triangle, I want to make sure that I get that other triangle or know if any exist at all. So here, the first thing I'm going to try to find is that side A across from the angle. And again, that setup fits really nicely into the law of cosines. So I'm going to plug in those other two side lengths of 6 and 10 and the cosine of that angle of 38. I'm going to put all of that into my calculator and then square root it to give me that A should equal 6.4. So remember, as we go to solve this triangle here, our solution here would include a side A as well as the measure of an angle B and the measure of an angle C. So far, we have the side A information. At this point, I can set up an equation using law of sines. Sine of 38 over 6.4 equals, and again, remember, I'm going to save my biggest angle for last. So the biggest side is 10, which means C is probably the largest angle. Maybe it's obtuse, maybe it's not. So I will find out by actually solving for angle B first. I will multiply both sides by 6 to get the sine of angle B alone. And then I will take the inverse sine of that decimal value to get B. And in that case, it should give you that the measure of angle B is equal to 35.3 degrees. And then my final step to solve this triangle would be to find angle C. And again, the measure of angle C is going to be 180 minus the sum of the other two angles, so 38 plus 35.3. And when you do that arithmetic, you should get that the measure of angle C is 106.7 degrees. And so that solves that triangle for me. All right, we're going to do one more. Okay, so I'm going to set it up. And then remember, you guys have the ability to pause whenever you need to if this is a little bit quick for you. So again, angles A, B, and C. Angle C is 23, side A 15, and side B 16. Again, I'm going to try and get this side C length as the first thing I'm looking for. And that sits up well in that law of cosines again. So I'm going to use those other side lengths of 15 and 16 and the cosine of angle 23. And again, I would type that whole thing into the calculator and then I would square root it, and that should give you that C is equal to 6.3. And so for this triangle, remember we'll be looking at, in order to solve it, finding side C, angle A, and angle B. And so right now we have that side C is 6.3. And then we're going to move on. Again, if there is an obtuse angle in this triangle, it would be angle B. So I'm actually going to find angle A first here. So sine A over 15 equals the sine of 23 over 6.3. And I would multiply both sides of the equation by 15 to get sine of A alone. I would then take inverse sine of that answer, which should give me the value of angle A, which should be 68.5 degrees. And then lastly, just like in the previous problems, to find the measure of angle B, that would be 180 minus the sum of the other two angles, which is 23 plus 68.5. And that should give us that the measure of angle B is equal to 88.5 degrees. And again, when we look at each of these problems, once we have the information filled in, we should have smallest angles across from smallest sides, and that any two sides of the triangle should be bigger than the third side together. So those are just kind of some checks that we can look at to make sure that all of our triangle information makes sense. So if you guys have questions, if you're watching this because you have questions and needed to see a few more examples, remember we have a discussion section specifically on this skill, okay? And that you can ask anything from any of the notes, the homework, or general questions that come up about using the law of cosines. So don't be shy about posting in the discussion or reaching out to me individually for a video or a chat or something to help get your questions answered.